Okay, welcome to meteorology. This week we're basically going to talk about monitoring the weather. So, what does that mean? Let me ask you the question, what do you think of when you think of what's the weather now? Because believe it or not, when I tell you the weather, I want to know the weather. I want to know what it is right now, not 10 minutes from now, not 5 minutes ago. I want to know the weather right at that moment. That's what weather means. Well, that's why a weather forecast is out in the future. Maybe 5 minutes out in the future, or it may be 10 days out in the future. So that's a difference. Weather means now. We look at weather and we're always trying to figure out what is going on in the weather. The better you understand and can define what's happening in the weather, the better you can forecast it out into the future, move it forward. So with that, here is a surface weather map. Looks kind of confusing probably to you, I'm sure. But you're going to see a lot of these this course, so you might as well begin to get used to it a little bit. On this surface weather map are plotted little tiny stations. These are called station plots. And each one of these represents the weather at, this was 18Z. Everything in the Weather Service and on weather is reference to Zulu time or Universal Time. It's basically the time it is in Greenwich, England. So current at that moment in time, 18Z, it would have been 1800 hours in Greenwich, England. For where we live, when it's Eastern Daylight Time, subtract 6 hours from that. So that makes it 2 o'clock in the afternoon. So this map was drawn at 2 o'clock on this Tuesday afternoon. These are a cold front here. Blue lines represent cold. Red lines kind of indicate warm. You'll notice that there is a little half moon on the side of it. Kind of represents a warm front. More like a triangle represents the cold front. And these, where they're alternating, are stationary. They're not moving. And on this chart, you can see all kind of H's and L's. They're high and low pressure systems. High pressure systems generally bring fair weather. Low pressure generally bring bad weather. Generally. You're going to find out more about that throughout the course. So if I were to look at a high pressure, and here's a high pressure pretty much over the Midwest of the U.S. right now. It's going to have probably fairly decent weather with it, fairly clear skies. If you look at a station symbol here, there's nothing shaded in. Shading indicates cloud cover. You see these up here? The more shading, the more cloudy it is. So with that, in the upper left-hand corner is a temperature of 72. In the lower left is a dew point, basically a measure of moisture. And then there are these lines, solid black lines here that go around. These are isobars. They're identifying a constant pressure. There are lines that are just hooked up to the same pressure. In this case, 1020 millibars. And guess what? You're going to get to draw some of these this week. Isn't that fun? But you're going to be drawing them, looking at a weather map, and trying to find these highs and low pressure systems. So basically, a high pressure system is where the pressure is highest. Low pressure systems where the pressure is lower. So now that we've kind of got a little feel for what actually defines weather, look at the wind flow around a high. The winds here are from the north. These barbs indicate the wind direction. So they're from the north. They go around like this. And over here, they become from the south. So basically, this has a clockwise circulation around it. And that is high pressure. The wind flows clockwise around it. So depending on where you are in relation to the center of the high is what your winds will be. Here's a low pressure system, and you can actually see northeast winds here, northwest winds here. This is counterclockwise around the low. Just the other week, I had a hurricane go near my house. I live down here in southeast Virginia. It went just to the west of me as it moved through. I had southerly winds, screaming southerly winds, but I had southerly winds on the east side of that storm. Now, Richmond was on the west side of that storm, and they had nothing but northerly winds. So you can see even a hurricane is a low pressure system of some form. So you've just defined your weather, looked at it. One other aspect I wanted you to get out of it is weather is three-dimensional. We're looking at the surface. If you were to look aloft, say at 5,000 feet, and wondered, where is this cold front at that elevation? The cold front is going to slope, and it's going to slope back into the cold air. So your cold front actually aloft is back in here somewhere probably. So if you were to be able to go up in an airplane, you took off from this area, you'd be in the cold air, and then all of a sudden you would pass through the cold air as the cold front dipped down below you, and you would be back in the warmer air again. So, and warm fronts do the same thing. They have a mound of warm air to their south. So again, there is a slope to the weather. It's three-dimensional. So that's something else you're going to have to get to thinking about in this course. In order to observe the weather, we have lots of stations out here doing it, but still we don't know everywhere. Say I was to ask you the weather, what it was between Columbus and Mount Vernon today, and I want to know exactly what it was. Well, you could probably tell me the temperature at Mount Vernon, and you might be able to get the temperature at Columbus, but I'll bet you can't tell me the exact temperature in between the two. And that kind of can be important for a weather forecast. Say there was the cold front between the two. You can see here, right along the Kentucky-Ohio border, that front. If that front's in Ohio, it may be just a little bit different weather. So depending on where I live, say I lived in Huntington, West Virginia, which is right here, maybe that's front south of me, maybe it's north of me, but you need a lot of data, a lot of weather information, current information, to tell me where that front is. The chapter also discusses radar, and you can see here Doppler radar mosaic over the whole United States. Say I was interested in looking along that front. We'll bring it in a little bit closer. And here's your thunderstorms, rain showers, all along this frontal boundary, just out ahead of it. We can also look at it through satellite. There are all kinds of curves in satellite right now to look at the weather. Many of them tell you a whole lot of interesting facts. Believe it or not, when you're looking through the atmosphere, a satellite looks at 16 different what they call channels, or a certain band of radiation. And then it combines them into images. So say I wanted to do an animation of geocolor, which is basically if you were to look down the sky and see it yourself, this is what you would see. Here you can see those cold fronts. Oh yeah, notice the clouds go to the north behind that front. So that's the slope. You can actually see thunderstorms down over Florida here, more along the southeast coast of the United States. There's a lot of heat going on out here in the west, and you can kind of see a big high pressure. Remember, we said it would look like it would be flowing clockwise? Well, look at the flow of clouds. They're kind of going north out here, coming south down here. This is an upper level high pressure. Again, three-dimensional. So you can see there's tons of information you can get from this. Say I wanted to know if there was lightning or not. We can look at lightning in satellite now. It actually picks up flashes of lightning, and when this moves here, you can see lightnings right along those thunderstorms. That's showers. We just showed you on radar, and more down in here. So, and I can look at maybe moisture. So maybe I would want to look at water vapor, we'll say in the mid-levels, which is about 15,000 feet. So here's water vapor. The whiter and the greener it is, the more water vapor is there. The yellowish, the drier it is. So you can see there's a band of very dry air going up like this, but lots of moisture along the southeast U.S. coast. So this is just giving you an example of looking at the weather, thinking about it. So when they're outside this week, try to picture what the weather means to you. What is that weather? And then you can start looking at it and comparing it, and we're going to learn about each one of these different points of weather: temperature, dew point, pressure, winds. All of that's going to be discussed in some detail throughout this course, and then we're going to put it all together looking at fronts and low pressure systems. So let me know if you have any questions this week. I hope you enjoy this course.